So for this one, the key to figuring out is figuring out what goes on bottom. Now, obviously what's going to go on bottom is total cars. Is what fraction of the cars have a sunroof. So on top is going to be sunroof. Excuse me. So that's easy to figure out. That's going to be what? How many of them have a sunroof? 18 of them. Well, 12 have both. That's actually included in both the 18 and the 42. I didn't say 18 have just a sunroof. I said 18 of them have a sunroof. 12 of them have both. So what that means is when we go to figure out the total, I have 42 that have power locks, 18 that have a sunroof, but 12 of them have been counted in both. So I have to subtract that 12 back out. And then I have 12 that have neither. So I have 42 and 18 makes 60. Minus 12 is 48. Plus 12 is 60. So there are 60 total cars. Both of which can be divided by 6. So I get 3 out of 10. So 3 out of 10 cars have a sunroof. You don't need to write this word down. This is something called the inclusion-exclusion principle, where you have items like this where they're not, we call exclusive. If they were exclusive, they have to fit into one of the categories and none of them overlap. Kind of like your grades. You either got an A, a B, a C, a D, or an F. Nobody got both an A and a B in the same class. So they're exclusive. There's no way you can be in both categories. Here they're not. It is possible to be in 2 categories at once. It's possible to have both power locks and a sunroof. When that's the case, then we have to account for those that are counted in more than one category. Any of you that go on to a 4-year degree at some point, very, very good chance that you're going to have to take a class in statistics. And if you ever take a class in statistics, you will deal with basic probability, and that is one of the things you'll have to deal with. Is inclusion-exclusion. Another place where this comes into effect, or that we would deal with counting, let's look at a breakdown of employees. So we've got employees that work hourly, and we've got employees who work on a salary, and employees that work on commission. Let's say their education, those people that have high school, there are people that have an associate degree, and people that have a bachelor's degree. So let's say of the people that are working in this particular company that have a high school education or less, we have 128 that are working hourly. We have 6 that are working salary and 5 on commission. With an associate degree, we have 42 that are working hourly, 8 that are working salary, and 6 on commission. And with a bachelor's degree or better, let's say we have 19 that are working hourly, 28 that are working salary, and 6 more that are working on commission. So we're going to fill in the total for each row and column here. I'm going to have you do that for me quickly. So find the total going across this way for each, then the total going down this way for each. So I'm going to give you guys a couple of minutes to do that, then we'll take a look at it. So going across here, how many total people do we have that have a high school degree or less? What's that? 139, okay. Associate degree? 56, and then bachelor's? 53. Going down here, how many people do we have that are working hourly? 189. On salary? 42. In commission? 17. Did anybody find the total? 248. Very good. So now that I have that, what if I ask you, what fraction of employees work on salary? Well, that's pretty easy. There's 42 that are on salary out of 248 total. Both of those numbers can be divided by 2. Which gives us 21 over 124. As promising as that looks, that's as far as we can take it. So 21 over 124 is the fraction that works on salary. What fraction work hourly and have an associate degree? So what this is saying here is hourly, here's associate degree, and means I have to have both. So that is the 42 out of the 248. Well, guess what? Once again, that's 21 over 124. Kind of a coincidence that those two came out to be the same. Does that make sense so far? Why it was just the 42? Because it's the only one that fits both of those categories, both of those qualifications. Now, this next one's going to be a little bit more difficult. What fraction work hourly or have an associate degree? So if I look at this, hourly is here, associate degree is here. So what I have is I have 5 numbers I should add together. I can add these numbers together, and then I have to add these to it. What do you get when you add those up? $203. So that's 203 over 248. Now there are a couple of ways we could have came up with that 203. One was to add all of them up. 128, 42, 19. Plus 8 and plus 6. But another way we could have done it, going back to what we saw at that previous example, we could have done 189 plus 56. Now that's way more than 203. Why would that be more than 203? Because there's 42 that are counted twice. So we could have done 189 plus 56 and then subtract the 42 that were counted in both. That would also give us 203. Does that make sense? That skill of being able to pick numbers out of a table or out of description is a big one for us as we get into more problem solving. and being able to combine with ands and ors. Important in this class, but even more important if you move on into the next levels. So we're going to leave that at that for now. How many of you have to take business math as your next class? Or math and business applications? No? No idea? How many of you are in a business program? Okay, so most of you will have to take math and business applications as your next class. So there is going to be, that will pop up again in there. Okay, so the next thing I want to look at is let's look at something like this. So when I go to reduce this, just like we were doing before, we're going to separate out the numbers, 24 and 32. You'll notice I left off the negative. The reason for that is when I'm dealing with a fraction, let's say I just have 3/4. Well, a negative out front of the 3/4 makes it negative. Negative 3/4, what's a negative divided by a positive? It's a negative, so that's equivalent. How about 3/-4? A positive divided by a negative is negative. So that is equivalent. All of those signify a negative. So when I have a fraction with a negative in it, if there's just one negative, I can just put that negative out front. The whole thing is negative. It's a negative number. So I don't have to include that negative here when I reduce my numbers. What can both 24 and 32 be divided by? 8. Good. 24 divided by 8 is 3. 32 divided by 8 is 4. So 3/4 is going to be the number part of this. The negative is going to be out front. How about x? Top or bottom? Top. Power of 3. Good. The larger power was the 8. It's on top. 8 minus 5 is 3. Y? Bottom and 2. Good. Larger power is on bottom, the 8. And 8 minus 6 is 2. So this is a negative 3x to the third over 4y squared. So here, is my resulting fraction going to be positive or negative? Positive. A negative divided by a negative is a positive. Well, if I reduce 50/30, what am I going to get? 5/3. Do I make that 1 2/3? No, I do not. It's just 5/3. So what happens with the x? Bottom, power of 2. Good. Larger power was on bottom. 10 minus 8 is 2. Where does the y go? On top, power of 2. Good. Larger power is on top. 12 minus 10 is 2. So 5y squared over 3x squared. We've looked at things like this. How do we combine the powers when we do that? Multiply the powers, yes. 7 times 3 is 21. When we have an exponent raised to another power, or an exponent within an exponent, we multiply the powers. When we had numbers and multiple variables, we separated each of them out. Remember, the count actually has to go to the power. So 5 to the 4th, is that going to be 20? No. 5 to the 4th is going to be 5 times 5 times 5 times 5, or 625. What happens to the x? X to the what? 8 times 4 is 32. And y to the 44th. So each piece gets done separately. If I have 2/3 to the 4th power, so that's 2/3 times 2/3 times 2/3 times 2/3. If I look at what's happening here, remember when I multiply fractions, I'm going to multiply straight across. 2 times 2 times 2 times 2 is just going to be 2 to the 4th power. 3 times 3 times 3 times 3 is going to be 3 to the 4th power. So 2 to the 4th power is 16. 3 to the 4th power is 81. If I have a fraction with variables in it, raised to a power, same thing is going to apply. I take each piece separately. What is 3 to the 3rd power? 27. There you go. 3 times 3 times 3 is 27. X to the 5th to the 3rd power? 5 times 3. X to the 15th. Good. 5 to the 3rd power? 125. Very good. 5 times 5 times 5 is 125. Y to the 2nd to the 3rd power? Y to the 6th. Yeah, why not? So here, it's tempting to jump in and do 18 to the 4th power, but when we have parentheses, first thing we have to ask, is there anything we can do inside those parentheses? Up here, was there anything we could do inside the parentheses to reduce that? No, there was not. That was as simple as it could be. Down here, however, there is. First of all, 18 over 42 can both be divided by what? 6. Which will give me 3 over 7. X, what's going to happen with that? Where's that going to end up? Top or bottom? Top, and power of 3. Good. 8's the bigger power. 8 minus 5 is 3. Where's the y going to end up? Bottom, and that'll be just a y. Now we can do the power. What is 3 to the 4th power? (81), right? 3 times 3 times 3 times 3. X to the 3rd to the 4th power. X to the 12th. Very good. 7 to the 4th power. That's a lot, yeah. I believe it's 2,401. Y to the 4th power? Y to the 4th power. So that's it. So let's have you guys try one here. See what you come up with that one. Okay, so for our first step, we've got to reduce the numbers. 14 over 35. Both of those can divide by 7. So that gives us 2 over 5. So we got 2 over 5 so far inside there. How about x? On top, what power? 5. Good. How about y? On bottom, what power? 5. And z? Top, what power? None, just z, or z to the 1. And now we've got to do the power of 6. 2 to the power of 6 is 64. 5 to the power of 6? Perfect, 15,625. X to the 5th to the power of 6. X to the 30. Z to the power of 6. Z to the 6th. And y to the 5th to the power of 6? Y to the 30. How many of you had 64 x to the 30th, z to the 6th over 15,625, y to the 30th? Good deal. One last example for you. Looking at this one, I've got my 28 over 21 that I have to reduce. And yes, I know there's a negative in there. We're going to talk about that in just a second. Both 28 and 21 can divide by 7, which will give us 4 over 3. Again, we have to make sure that we do not try to split that into an improper fraction. Back to this negative. It's going to be either we can either leave it with the 4 or we can put it out front, but we're going to be raising this to a power of 4. That is an even power, and what do we know about even powers when it comes to negatives? Yeah, the result will always be positive. So even though that's a negative right now, and technically we have to leave that negative in there right now because we haven't done the power of 4 yet, but we know that our result better be positive. So how about the x? Top and power of 2, y? Top, power of 3. Good. Now I'm just going to drop the negative because I know it's going to cancel out. I mean, I could do negative 4 to the power of 4, but 4 to the power of 4 is going to be what? 256. X squared to the power of 4? X to the 8th. It's going to be y to the 12th. Good. 3 times 4 is 12. And then 3 to the power of 4 is 81. Any questions? Okay. Did you ever find that one you were looking for? Or? No. Okay. For now, we'll turn you loose. There is a new quiz that is due tomorrow. That is Tuesday by 11:59 p.m. And there is a new homework that is going to be due for Wednesday in class. So I'll give you guys the last 18 minutes or so if you want to go next door in the computer lab and get started. I would recommend you do the quiz first. Otherwise, we'll see you on Wednesday.